cannot be integrated the way it is written, or was just going to be really, really ugly. And when that happens, one of the tools that we have for double integrals anyway, is to try switching the order of integration. So if I look at this, and I was going to try to integrate this with respect to x right now, integrating the square root of x cubed plus 1, there's no u substitution I can do. It's possible that there's an integration by parts that might help me. I think I might have to use some sort of trig identity and do a trig substitution. Like, it's not friendly. Luckily, we've been given the hint to switch the order of integration. Now, I'm going to do it the wrong way first. You might think that we can just switch the order of integration. There's a problem with this. Negative sign is not the problem. There's a problem with this because this thing we can think of as representing some sort of volume. And the very last step we're going to have on this one, after I've taken the antiderivative with respect to x and after I've taken the antiderivative with respect to y, I'm going to plug in 1 and 0. Whatever happens, I'm going to get a number out of this integral. I'm not going to get a number out of this. Because if all I do is literally flip the order of integration, the last thing I'm going to be plugging in is a square root of y. My answer was going to have y's in it. So this doesn't work. And instead, in order to switch the order of integration, we actually have to go back to what the picture looks like and rewrite it with our cross sections the other direction. So I'm going to start by constructing the picture. And my picture has to start by drawing all 4 of these bounds and reminding myself this was y equals 0, y equals 1, x equals 1, and x equals the square root of y. So if x equals the square root of y, that means y was equal to x squared. But this only takes into account positive y values, or rather it only would spit out positive y values. So y equals x squared would be an entire parabola. But if x equals the square root of y, a square root can never spit out a negative value. So that means I wouldn't have any negative x values. And then I have x equals 1. I have y equals 0 and y equals 1. So in terms of the region in question, sometimes, like in this case, there's kind of 2 parts to my picture. To figure out which part we're looking at, I'm going to put my pen on the inside lower bound, like whatever that graph is. So I'm going to start here on the curve that's the inside lower bound, and I'm going to move in a straight line to get to x equals 1, which means right now I have a horizontal cross section. And I have to flip that. So if I'm going to flip that, it means I'm going to end up with a vertical cross section. And that vertical cross section, my inside bounds, the function at the bottom is y equals 0. And the function at the top is y equals x squared. I would take those vertical cross sections as far to the left as x equals 0 and as far to the right as x equals 1. When we switch that order of integration, we haven't done anything to change that interior like height function. The only thing we're doing is changing the bounds. And then we're ready to integrate. This one, I will give you a chance to integrate on your own. After we switch the order of integration, is with respect to y, that whole thing is a constant. So when I find the antiderivative, it's just going to be y times that whole thing. And now I'm plugging in 0 for y and x squared for y. When I plug in x squared, I end up with something where I'm going to have the u substitution waiting for me. When you plug in 0, 0 times something, it's gone, so I don't have to worry about that part. Yeah, sorry. So now the u substitution is sitting there waiting for me. And if I let u equal x cubed plus 1, then my du is 3x squared dx. And I've got the x squared and I've got the dx. So I just need that 1/3 du is equal to x squared dx. I'm going to go ahead and switch my limits to be in terms of u as well. So if I switch my limits, when x equals 0, u is equal to 1. And when x is equal to 1, u is equal to 2. And that's going to let me switch my limits to say I'm actually integrating from 1 to 2 of 1/3 u to the 1/2 du. So all of those fun integration techniques from 19B and all of those integration skills we had last quarter, they're coming back around. We're going to need them right now, and we're going to need them when we dive into chapter 14, which is going to happen on Friday. So here, adding 1 to that exponent, I'll have u to the 3/2. So when I plug in 1 for x, I'm going to have 1 cubed plus 1. Yeah. So I'll have u to the 3/2. I'm dividing by 3/2 or multiplying by 2/3, which means I think I'm going to have a 2/9. And now I'm going from 1 to 2. So I've got 2/9 of 2 to the 3/2 minus 2/9 of 1 to the 3/2. So let's pause for a second and look at this and say, why might I want to switch the order of integration? Well, the way it's written right now, to compute the dy part, I'm going to have to do integration by parts twice. Maybe that's the route we want to take. Or maybe we want to look at that and say, well, it doesn't take that long to switch the order of integration. Let me see if the other integral works out better. So if I get my drawing going, I'm going to have y equals x, y equals 1, x equals 0, and x equals 1. So again, I end up with a picture that has sort of 2 regions. And the way that I'm going to figure out which one we're talking about, I'm going to put my pen on the lower inside function, and I'm going to move in a straight line until I hit that upper function. And since these were both y on the inside, that means I'm going from there to y equals 1. So currently, this is a vertical cross section. And the area we're looking at is this upper triangle. So if I need to switch that to be horizontal cross sections, then when I switch it, my inside limits, my left-hand side is x equals 0. My right-hand side is x equals y. And this is going from 0 to 1 in the y direction.
How did you get the red cross section? In the middle of one?
Yeah, so I'm gonna start and I'm gonna put my pen on the function that's on the inside bottom. Just like basically in the middle somewhere. And then move in a straight line until I hit the upper function. Whatever is up there. So this time what was up there is y equals 1. So I had to move straight up. In the other example, dx was my inside. So when I moved in a straight line to hit x equals 1, that meant I had to go to the right.
I'm confused, like, how do we do this, respect to x respect to y? We see, should we see it from here?
Like, how do I know what it is originally? So if dy is on the inside, that means that I have a vertical cross section. If dx is on the inside, it means I have a horizontal cross section. Oh, I got my colors mixed. Let me not do that, because then the colors don't match my picture. Eee. Okay, sorry. This inside function. I got my orientation right. I just want my colors to match the picture. Sorry about that. The other way you can think about it is that the outside integral is the 19b integral. So the outside integral always has to be the one that's got numbers. And what the outside integral is has to match what your 19b integral would have been.